Hi, in this video we're going to look at writing recurring decimals as fractions. This is quite a small topic but quite often appears on a higher GCSE paper. It's worth a few marks, 2 or 3 marks typically, and is quite an easy thing to be able to do, but quite often people forget how to do it. So I'm hoping this video might be useful, a little bit of practice to be able to do these sorts of questions. Okay, let's see what we're going to do in this video. All I'm really going to get you to do is to use an algebraic method to write a recurring decimal as a fraction, and I hope that you're quite happy that a recurring decimal is something that might look like 0.34, and this dot on the top, it just means that the 4 recurs, so this would be equal to 0.3444 and so on and so on and so on. I'm hoping that you're also fairly comfortable with the idea that if it looks like 0.106 with dots above the 1 and the 6, this means 0.106, 106, 106 and so on and so on and so on. A final little example might be 0.324 with 2 dots over the 2 and the 4, which would mean that the 2 and 4 recur. So that would be 0.3, 24, 24, 24, and so on and so on and so on. So these are the sorts of things that we're going to look at. I'm hoping that you're happy and comfortable with the notation. It's as simple as looking at where the dots are, and that tells you which parts recur. Okay. First example then. We've got 2 examples here. It says write each recurring decimal as an exact fraction in its lowest terms, and it starts off looking at 0.5 recurring. So what we're going to do is we're going to say let x equal 0.5 recurring, and remember that this means 0.55555 and so on and so on and so on. Now the idea behind the algebraic way of doing this is that what we're trying to do is we're going to end up multiplying our x by either 10 or 100 or 1000 or some multiple of 10 to enable us to effectively take one of our equations away from the other to get rid of our decimals. Let me see if I can show you. So x, we said, was 0.5 recurring. Well, that's like 0.55555 and so on and so on and so on. If I multiplied this by 10, then 10x would be, remember that what's happening is all the numbers are moving one place to the left, or if you like to think of it as the decimal point moving one place to the right, then what we say is 10x would be 5.55555 and so on and so on and so on. Now if I ended up taking this part here away from our new 10x, I'm hoping that what you could see is that our numbers that line up above each other, if I'm taking these away from each other, they're going to effectively cancel out. So our normal x, what we started with, x was just 0.5 recurring. So I'm going to say that x underneath equals 0.55555 and so on and so on and so on. If I do a takeaway now, then 10x minus x leaves me with 9x. Don't make a silly mistake at this point and think that 10x minus x is just 10. You're going to lose lots of marks by doing that. 10x minus one of the x's is 9x. And that equals, well, starting at the left hand side, so starting over here, 5 take 5 is nothing. 5 take 5, nothing. 5 take 5, nothing, and so on and so on and so on, until I get to 0 from 5, which just leaves me with 5. I've managed to use an algebraic method here to get rid of all my recurring decimals, and the point of the algebraic method is to try and do this. By setting it out in this way, I can take one equation away from the other equation, and that gets rid of the recurring decimals. Okay, well, I now know that 9x is equal to 5. Simply rearranging this now gives x equals 5 over 9. I've done what it said in the question. It said write the recurring decimal as an exact fraction, which I have done, in its lowest terms. 5/9 is as simplified as it can get. I can't simplify that anymore. 5 is a prime number, and nothing goes into 9 other than 1, 3 and 9, so I can't cancel that down any further. Good, I've done the first one. 0.5 recurring is 5/9. Let's have a look at the second one then, 0.7 recurring. Okay, let's just get rid of some of this. Okay. Right, 0.7 recurring then. Let's start. So let x equal 0.7 recurring. That means that x is 0.77777. I'm going to multiply this by 10. So 10x would be 7.77777, and so on and so on and so on. X, we said before, was 0.777777, and so on and so on and so on. Take one away from the other. So 9x equals 7. That means that x would be equal to 7/9. Again, exactly the same as the first one, but instead of having 5s, we've got 7s. It might be after you've practiced a few of these, you start to notice a pattern, but to get full marks on these sorts of questions, you have to show the algebraic way. Okay? Right, let's have a look at a slightly different example. In this example, it says to write 0.24, both recurring as a fraction in its lowest terms. Before we do anything else, let's just think about what this means. 0.24 both recurring is 0.24242424, and so on and so on and so on. Now, if I multiplied this by 10, so if I were just to multiply by 10, then I'd get 2.42424242, and so on. Now, at this point, my decimals don't line up. I don't have the same number above and below, which means that if I take one away from the other, I'm not going to eliminate anything. I'm just going to have a huge list of decimals still. That's not going to help me. So instead of multiplying by 10 this time, what I'm going to end up doing is multiplying by 100. So let's see what happens if I multiplied it by 100. So if I times that first one by 100, I'd get 24.24242424, and so on and so on. Now this time, so we've decided we're going to eliminate this one. This time I'm hoping that you can see that the numbers do line up. Okay, so these line up. When we take one away from the other, just like in the last example, we're going to be able to get rid of our decimals. So what we can say is let x equal 0.242424, and so on and so on and so on. That would mean that 100x would be 24.242424. Okay, 100x minus the x. So I've got 24.24. I'm setting it out almost like a column method now. So 0, x was 0.242424, and so on. Take one away from the other. Right, 100x minus x leaves me with 99x, and here I've got 24. So this time, rearranging, it says that x is 24/99. Okay, now it does say as a fraction in its lowest terms, and I'm just checking at this point, is there anything that I can do to simplify this? Well, I can see that 3 is going to go into 24, and 3 is going to go into 99. So if I'm simplifying this down a little bit further, and again I'm going to do it up here, 3 goes into 24 8 times, and 3 goes into 99 33 times. So I've had a little bit more work to do on this one than previously. This one might be worth a few extra marks as well for doing the extra simplifying down. But again, whenever we're looking at fractions, we're just checking that this is the case. If you're not sure whether something's divisible by 3 or not, there's a very quick trick that I can show you. If you were to add the two numbers here. And if you add these two together, so 2 and 4 is 6. 6 is in the 3 times table. So that means that it's divisible by 3. Let's add these two. 9 and 9 is 18. 18 is in the 3 times table. That means it's also divisible by 3. So as a very quick check, you can do this if it's not something that you can spot straight away. The 3 times table is quite an easy one. Add the digits. If when you've added them, that's divisible by 3, then that actual number is divisible by 3. Okay, fantastic. Right, let's move on to look at the third. In this example, we're going to look at changing 0.207 into a fraction in its simplest form. Now, 207 all recurs. So we've got, so if we said let x equal 0.207 recurring, if I multiplied it by 10, I would get 2 point. Before I do that, let's just see if we can think about what this means. So this is 0.207, 207, 207, and so on. To get these numbers to line up, again, you might be able to spot that what I would need to do is move my decimal place 1, 2, 3 places, or if you're doing it properly, you're moving the numbers to the left. I still think about moving the decimal point, although it's technically wrong. I'm moving that 3 places. That means I'm going to have to multiply by 10, 100, 1,000. So let's do that. Let's straight away jump ahead and say let 1000x would therefore be 207.207, 207, 207, and so on. X was 0.207, 207, 207. Notice again what I've done here. I've lined up my units. So the 7 unit and the 0 unit, I've lined up my decimal point and I've lined up all the numbers. When I take one away from the other, I get 999x equals 207. Rearranging, x equals 207 over 999. Okay, so let's have a look for these 4 questions. I want you to have a think about how you're going to do these yourself. Question 1 over here is very similar to an example we've just done, as is question 2. Question 3 and 4 are going to take a little bit more thought. What I would do is write out question 3 as 0.277777. Think about what you need to do to be able to get the decimals to line up. Take one away from the other, rearrange it, and look at your answer and see if it kind of makes sense. If it doesn't, again, see what you can do just intuitively to see what you can figure out there. I'll show you what to do in a few minutes anyway, but have a go at these for yourself. Pause the video, try them, and then we'll come back and I'll show you the answers. Okay, so for the question 1, you should have got 75 over 99. For question 2, you should have got 216 over 999. Now, for question 3 and 4, it was a little bit more tricky. I'm going to show you what to do for question 3. So 0.27 recurring looks like this. Okay, if you multiplied it by 10, so if x was equal to that, 10x would be 2.777777 recurring. The 7s do line up, so if we took one away from the other, 9x would give me 2.5. Rearrange it, x would be 2.5 over 9. Now, this doesn't look right. I'm pretty sure that your teacher or me, I will never have left a fraction in terms of a decimal part. It just doesn't look right. It doesn't kind of make sense, really. We're going to have to tidy this up a little bit. Now, I'm hoping that you're happy with fractions, that whatever you do to the top, you do to the bottom. To tidy the top up, to make it look right, I could double it. That would give me 5. If I doubled that, I'd get 5. Double the bottom, and I get 18. You might have multiplied it by 10 top and bottom to get 25 over 90, but again I want these in its simplest forms really. I did say recurring decimals as fractions. Leaving it as a fraction is fine, but more often than not the exam question would tell you to do that in terms of in its simplest form. Okay, so you would get that for this one, and for the final one, see if I've got enough room over here, then we would get 0.72888 and so on. If I multiplied it by 10, I'd get 7.2888 and so on. If I take one of these away from the other, you would end up getting that 9x, so I'm kind of skipping a step here, but you should get 9x equals 6.56 over 9, which doesn't look very nice. Multiply top and bottom by 100, sorry, so you get 656 over 900, which then you might be able to cancel down. I can see straight away that you've got to half top and bottom, and you could have a go at doing that until you get to something that makes sense. Okay, and that would be 164 over 225. So if you were cancelling it down as far as it to go, this would be what you're looking for. I'm happy at this point if you're getting solutions that look like this. You can then have a go at cancelling it down. You've done the hard work to get to that point, and you've shown algebraically all you're working out as you go through. Okay, videos all the way through the series, then you'll see that at the end we do some revision card notes. You might want to make a little note of what recurring decimals look like. So you might want to say 0.3 recurring is the same as 0.3333 and so on. You might want to give yourself another example where both numbers recur, 1.1414, oops, 1414, 14, and so on. And you might want to give yourself an example where only the last one recurs, so 0.612 recurring is 0.61222 and so on. I've put over on the right hand side some ideas about what you could write in your revision notes. So you can say let x equal the recurring decimal. We're then looking at multiplying either by 10 or 100 or 1,000 or whatever you need to do to get these decimals to effectively line up. You're then going to subtract one away from the other, remembering to subtract your x's as well. Then you're going to rearrange and solve and finally simplify. Okay, so as a final clue, simplify where possible. Okay, hopefully this has been useful. As ever, I'm wishing you all the best of luck in your exams, and keep watching the videos, keep working hard, and success will come your way.